Abstraction. Let's start with some terminology and definitions. Abstraction and information hiding are two sides of the same coin. Information hiding is the process of hiding details, whereas abstraction is the result with details hidden. So here we have a square with some circles in it. Let's hide a couple of these circles. So here is abstraction in action in a very simple manner. Definition. Abstraction is a model of a complex system that only includes the details that are essential for the viewer to know, so as to allow focus on the main processes, stroke data, and ignoring the details the viewer does not need to know. Advantage. We can say abstraction is a useful tool to reduce the level of complexity of a system. An abstraction allows a programmer to implement a system properly. Okay, abstraction in a real-life context. Example 1. So here we have Rory the dog. Here we have the owner. So how does the owner view her as? The owner views her as a household pet that wags its tail and leaves dog's hairs. The vet views Rory as a mammal with organs, flesh and bones that need medical care. And the farmer views Rory as a working dog helping to round up the sheep. So you can see there are different views or different forms of abstraction depending on the viewer. And we say there are different abstract representations of the dog. We say that the owner, vet and farmer use different abstract representations of the dog. Example 2. So here we have a car. This is the driver of the car. So what does the driver of the car need to know? The driver of the car needs to know how to drive the car from point A to point B. And for that purpose, the driver only needs to know how to interact with the car. The driver needs to know how to interact with the pedals, how to interact with the steering wheel, but the driver does not need to know about the internal workings of the car or how the engine functions. So we use abstraction to reduce the level of complexity of a system. Or we can say abstraction is a useful tool to reduce the level of complexity of a system. Example 3. So here is a school with students. So the school kitchen will need to know the number of students to cater for, allergies they have, food restrictions, food portions, the times of the lunches. The school teacher will be interested in the names of the students, what subjects they are studying, any special study requirements, what level they are studying the subject, and how many students in each class. These abstract representations differ in the type of information the school kitchen and school teacher are interested in. Okay, let us look at abstraction in a programming context. Example 1. So we have the casual user. So the question is, how would a casual user view a software package, i.e. program, such as Word, Excel, etc.? Answer. The casual user would only know how to use the software, i.e. run the program. They only see the surface of the program. Here is the casual user. He wants to use a word processor and write the words hello world. He only needs to know how to write the words hello world, not the internal workings of the word processor. Example 2. So how does a programmer or person who implements a program view the program? Well, answer. This person will start with the algorithm and he will need to understand it thoroughly in order to implement it, i.e. to program it. The person or the programmer must understand the inner workings of the program. Here is a program. Add two numbers, x equals 10, y equals 12, total equals x plus y, print total. Example 3. How does a programmer use modules? Written by another programmer. So answer. The programmer only needs to understand the input and output of another module written by another programmer, so he or she can incorporate that module in his or her program. The programmer does not need to understand the inner workings of the module. So here we have a module called random. So we import random. And here we have the statement random.randit 1, 10 generate a random number between 1 and 10 using the random module. So that's the input. And whatever it has generated, we assign it to the variable r, which is the output. So here you can see that the programmer only needs to know about the input and the output of the random module, print r. So this is an overview of abstraction. We hope it helps. And that's all for now, folks.